Hello explorers and welcome to another video. Today we are going to talk about OpenStack and we're gonna install an all-in-one solution of OpenStack using something called Kayobe. And Kayobe is something related to Kolla, which is an Ansible script in order to install OpenStack. What makes Kayobe a little bit special is that it can actually install an all-in-one solution that doesn't take up that much space, RAM, and other resources. So you can play around and work with it. If you're installing an all-in-one solution with Kolla, I would need 32 gigabytes of memory on one system, which is pretty much what I have in my system now. So that would be a little bit much. And running a full-sized solution of an OpenStack, you need multiple servers that should be kind of beefy as well. And I don't really have that hardware available at the moment, so I can't really do that. So what is OpenStack then? Well, OpenStack is a solution where you can run services, compute nodes, and run compute workloads in a cloud where you have other resources like networking and storage and so on handled by different services. So OpenStack is not really one application, it's a bunch of services that handle authorization, network and so on, and they are packaged as one big project. So that's pretty much it. And let's just jump right into it here. There we go. And first off, I need to install a Python environment, a Python dev environment, and also a virtual environment for Python GCC, so we can build things, and also libffi development. So let's install that. This is otherwise a completely normal Debian bullseye install, so nothing extra in this environment. So we install these four packages in order to get what we need to run Kayobe pretty much. And other than that, I also want to install Git, because we are going to use Git a bunch to get the source code for Kayobe or the configuration for Kayobe. We need curl to download some things, and also NetTools is good to know when we want to look at open ports and so on. So let's install a bunch of more packages here, but these are more helper packages and not really related to Kayobe. And now we want to create a directory called Kayobe and put ourselves in that directory. And then they suggest that you also create two other directories, source and VNVs, so virtual environments. And we want to create a virtual environment for Kayobe there. So this is some feature that you have in Python where you can have a virtual environment and then go into that and install your Python packages there, so you don't clutter up your system. So let's create this Python virtual environment and activate it by source, and in the bin directory of that we created, there is an activate script that we can run. And now we see that we are in the Kayobe environment here. So we have a virtual environment, and now we can install the latest version of pip here. So we upgrade our pip, so the Python installer program or something like that, or packaging program. And then we install Kayobe. So this is a normal pip package. This will take a little bit of time. And you see here that it also installs the Python libraries to handle Ansible. So Ansible is scripts that will be run on the server in order to install a bunch of things. So now that we have installed Kayobe, we need to do a bunch of configurations. So first off, I want to add tab completion. So I run Kayobe complete into a file, and then I can source that file. So now I have tab completion in my interface here. So then we need to add a network interface. So I will add BR0, which is a bridge interface. I will put that up. And then I will add an IP address to that, and this is 33 1.3. So this is a network that I'm not using at the moment, but will be used by all the internal services within my system here, or this OpenStack system. And then I do the same to add a dummy interface that has this interface as its master. Then I will go into the source directory here and download the latest source of OpenStack Kayobe configuration. But here you say that you want to take out the branch master. But I had some problem with running master lately when I did this yesterday. So I will actually do version 11.0.0. Master might work for you now. They might have fixed it, but I had some bugs with the latest configuration when I ran master yesterday, so I will not do that today. Then we'll go into that directory that we just got out, and I will remove this host example file because we will not use that. And then we will edit the host file, which is not available here, and we will add some configuration to this. To know which host we have localhost, which is the Ansible local connection. We have controller 0, and then we have compute nodes, which is all the controllers. So this is just so we can get the all-in-one solution in one server. So this is not that many hosts that we have. Then we want to edit the controller's network interfaces, so the interfaces available for the controller. And here you see that there is a bunch of different networks that should be supplied here, but we will create only the interfaces that we need, and it's an all-in-one interface here. So this AIO interface, which is BR1, and then we can have a bridge port over this dummy network. So we don't add that many networks. That is otherwise a thing in OpenStack, that you have a bunch of different networks that handle different traffic for the different hosts. Then we have the networks. We need to define those. And here you see that you have admin OSONet, OOBnet, provisionnet, and so on. There is a bunch of different networks that you could provide here, and a bunch of configuration for each of them. But in our all-in-one solution, we will pretty much set them all to the same network here. So we will go in here and say that we will have the admin OSNet to AOE, where internal net should be the same network, the external network names is the same network, public net name is the same network, tunnel net, same, storage net, same, and storage management set is also the same network. So we will use the same network for everything. And then we will put up in a VIP address here, and also the actual network range that we will work in. So I guess that this VIP is the actual node that we connect on. And next up we will have this network allocation. And in here we will just add one IP address, and that's number 3, and that was the one that we defined on our dummy network or our bridge network. So now we have allocated that as our out endpoint, so we can reach out that way. We will not use that actually more than connect our graphical interface to it. And then we need to set some globals as well, and here is also a bunch of different things that you can configure, because Kolla has a lot of these. But we will keep everything as is, and pretty much nothing is defined. It's just this workaround here. But we will add our OS distribution, which is Ubuntu, and disable SE Linux do reboot. And this is if we need to reboot something and we have SE Linux installed. We will not just do that. At the moment we don't have SE Linux installed, but yeah, it's good to define that. Ubuntu is one that is available in this configuration. They don't have Debian. So I supplied Ubuntu, which is a Debian clone, so it would be fine. And then last but not least, we need to do a little bit configuration in the controllers. not much. Here we have also a bunch of things that could be configured, network interfaces and so on. But the only thing we will add here is the controller bootstrap username. So this is a local username that could be used to configure your network. So I will put in my local username here in order to be able to install packages and so on. And then we need to do more Kolla specific globals here. And this is just extra globals for Kolla. And we will add some here. There is a lot of text here, but pretty much we will say that the Nova Compute virtual environment should use the QEMU, the Q emulator, in order to run those. And we want the OpenStack service workers to be 1. So we are limiting our numbers there. And then we can add all the changes that we did here. So we add the host and the network allocation, and then add the other files here, and we will commit them. So this is just git commands in order to commit things in here. So now everything should be committed to the branch. And we can also go into this Kayobe environment. So they have prepared a script here, so we can change over to that configuration here. After that, I go in with sudo, and here I will actually add that my user can do anything without any passwords. And that's a simplification on this test system and not something that you should do usually. But as this is the bootstrap user, I want it to be able to install any packages that the Ansible script want to install without supplying any passwords. And we also need to go in to edit our hosts file, because it will take the local host IP address here and use it for the new IP address it will have in the controller network instead. So I will just change the name of this to host, so I know that this is the host address, and then we have a bunch of guest addresses within this host. And then after that, we start to bootstrap our system. So we run Kayobe control host bootstrap. And this will run the Ansible script in order to bootstrap our host system with everything that is required here. And this will take a while, so I will pause the recording here and get back to you when it's done. And we are back. So now we have bootstrap the host configuration, and now we need to take this over cloud, which is the cloud configuration, and put that on our host. So we will configure our host with the configuration that we just set. So this will run another Ansible script, go through and create passwords for us, and create users for the different systems, and configure everything that we defined in these different configure scripts. So we will be ready to actually install this all-in-one solution. And this will not take that much time, so I will wait for it to finish here. Yeah, so now that we have done that, we have a pretty large password file here, because there is so many different services that require different credentials here. There is a bunch of different passwords and keys that is required. So we will add that file into our GitHub repository as well and commit that, so we have that here as well. And it tells me that if you want to commit anything more, you should probably supply a password here. So let's do hello at danielperson.dev, and then we have my name. Who's your name? Daniel Person. So now I should be able to commit it. Yeah. And the next thing up is actually to pull all the images, because this is running in a Dockerized environment. So it will pull all the images down that is required to run this system. So we can deploy and install them later on. And this will also take a while, so I will pause here and get back to you when it's done. And we are back. All the images are now pulled. and we can start our deployment. So this is the way to deploy the Kayobe system and all the services. And this will start up the Docker environment and push all the images in there. And this will also take a bit of a while. So I'll get back to you when that is done. And we are back after a lot of installation. And now we have pretty much everything that we need in our environment. We have a running OpenStack cluster, but we need to test it out a bit. So let's install the OpenStack client so we can do some testing and do some work with this system. So first off, it's just a pip package, so need to install that. Would not take that long time, I think. And now it's installed, and then we will set up a bunch of different network configuration here. We will set the external network range here, the gateway address, and also the network range. The network range here, between which IP addresses you can create things. And then I want to run this administrative script so we can have an OpenRC connection to our Kolla script here. And the reason we do that is because we want to run this Kolla source path tools run once. And this will pretty much run through and set up a bunch of different configurations that are good when you want to run things locally in a test environment. So it will give you an image of the Cirrus image. So it sets up a region for you, it sets up other network connections and so on. So it pretty much creates some kind of test environment where you can deploy services to. And the one service that is available in this test network is this Cirrus service. So let's wait for it to run through and just configure up a bunch of things here. So there it's done. Now we can actually create a service that can run in this system. And I will pretty much copy paste what it's saying here. But what we're looking at is that we want to create a new service. And it's going to be the Cirrus image that we are using. That was deployed by the script above. We also wanted to run on a tiny node. So that's a configuration on how much memory it should have, how much CPU powers and so on it should have. There is a bunch of different, you have this MX large up here that you can install. So you have 16 gigabytes of memory and so on, and 8 virtual CPUs. And then we want to have a key name, and that is something that is in the script. It also installed this my key is a key that is used between the different services. So it's installed here. And then we have the network, which also this network was set up by this init1 script. So the demo net, we will use that network. And then the name of the actual server that we will start. We call it demo1. And let's run that. And now it's deploying that and running it. So it has scheduled a task to actually push that image into something that can run. We want to create a new floating point IP for our system so we can actually reach this network resource. And if we go up here, we see that we got a floating address of 193 in our system. So then we can just add that floating IP here to demo 1. So the new server that we create, demo 1, we want it to have this new IP that we have created, 193. And when we run that, it will connect those two so we can actually log in. It will take a while for this service to get up. So I will run another script here just to see service list. So this is a list of all the services that are installed and up and running. So we can go through these. First off, we have the glance, and this is the image service. So when we install images that could later be deployed as running computing resources in our system, glance is the image repository that holds all of those. Then we have Keystone, and this is an identity service where you create all your users or your groups and everything that can handle different authentications between different services and so on. Then we have the Nova Legacy. This is a compute node that could actually run all your services. So when you are starting a new container, it will be running by Nova. Nova will handle that thing. Then we have Neutron. This is the network management. So when we create a new floating point IP, it will handle that and provision a new ID for you and also connect and so on. So you know how the network is. Placement. And I think that is just a service for where to place things. It could be connected to this heat, which is an orchestration service that can handle where storage should be put, where network resources should be handled, and so on. So it can configure your cloud a little bit. So that's the different services that we are running at the moment. So let's see if we can log into this newly created server that we put on IP 193. And it asks for a fingerprint, and now we're logged in. So this is a Linux environment. We can check the OS release here. We see that we have a build root. It's a 2019 image of build root. We can take a uname here. We see that in Linux, let's do all. We see that this is called demo 1 and so on. So we're in that system. Now we can do things with this image if we want. So that is how to get a service up and running. There is a way to actually create a dashboard so that we can go in and run. This dashboard is also called Horizon, if you find that name anywhere in your OpenStack system. And there is a bunch of different services in this cluster that you can add for maintenance, for monitoring, and so on. So there is a lot of different services that is connected to the same system. I want to activate this, and I want anyone to be able to connect. I don't want the dashboard to be HTTPS. So now it will install this dashboard and install Apache and so on, so I can actually run this locally here. And then we just need to configure it, and we can look around a little bit after that. So let's just wait for that. And we are back. Now we just need to configure this OpenStack dashboard, and that is done by going into etc OpenStack dashboard, and then there is a local settings py, and we need to use nano in order to configure that at the moment. Here we can go in and first off remove those two lines here, because those are not correct. We're not on the local host, and this identity keystone URL is not correct either for this version. So if we go down in the bottom here, we will add our configuration that I have prepared over here. So first off, we have the OpenStack host. We said that that should be 3 earlier. Then we will add this caching engine, and this caching engine should use memcache D. I'm not sure if this service is running. We will look into that, but if it's not running, and then we will have to log in over and over and over again, because it can't really remember if you were logged in or not. But if this is working correct, the interface will work better for you. And then we will have this URL here. You see that the identity slash here is not there. We are using version 3 instead. So up here we had version 3 as well, but we had slash identity. That is not needed. And then we say that we want to log into the default domain. Otherwise, we will have to say that we want to log into that domain, which is not something that we want in our login GUI. And the default role that we will log in with is a user. So let's save that here. There we go. So now we have updated that script. We also need to go into Apache porch and add this local IP. And it was 105, I believe. And the SSL is not enabled, but we can add that as well. 105. And the last one. 192, 168, 6, 105, just so we don't use the bridge network here. Now we have updated that. Now we should be able to do system sudo system cdl status apache 2, and then we should be able to restart that service. And now it should be up and running. And what we need now is the password. And we know, remember this large password files with a bunch of passwords in it. I will grep for the Keystone admin password. So we have that here. And I will copy that. If we then go over to our web browser here and go to 192, 168, 6, 105, we should get to a login interface for the OpenStack service. And we can go to admin, put in that long password, and we should have a dashboard where we can see things. And it takes a while for it to load. Now we see that we have one instance of 40. We're using one virtual CPU of 40. We're using 512 megabytes of RAM. We have 93 gigabytes. I don't know where it got that from. We have a floating IP. We have one security group, one role, 2 networks, and 4 ports, and 1 router. So we see that we have some things here. If we go over to instances, this doesn't seem to work that well, so we need to log in again, see if that works. So now we can see that we have demo running here. We can see which IP it has externally and which one it has internally. It's tiny and it's running at the moment. We can go into images and see that we have, images is not working, it seems. Let's see if we can log in again. Let's try key pairs. Yeah, so this login interface is not working that well without that service. Network topology, let's see if we can see that. It takes a while for it to load. Should get a graph or some kind of topology here, if it's able to get there. Yeah, and we can look at the networks. So we have demo net, the public net. We have routers, demo router, security group default, floating IPs. We have this 193 that we created, and it's connected to this internal IP. And then we have the admin interface. We can look through the compute nodes, different networks, and we can look at the system. If we do system information, we can see here that we have Glance, Keystone, Nova, Neutron, placement, and so on. So we can see all the services, all the different URLs that we can look at each of these services, both as an admin, internal, public. And we see that all of them are exactly the same IP. And that's because we aren't having all the extra networks set up in this all-in-one installation. But if you are installing this in a production environment, you need to handle a bunch of different network interfaces and so on. So a real installation of OpenStack is quite complex and requires a lot of work. And I'm looking into that as well, but I'm just scraping the surface at the moment in understanding everything that OpenStack has to offer. But I hope that you found this interesting. I hope that you learned something today. Are you running OpenStack today in your environment? Please leave a comment in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.